Today's AI are computationally intensive and memory hungry, and so most AI demand powerful CPUs and GPUs. The two major challenges to bring machine learning inferences to ultra low power devices are power constraints and memory constraints. TinyML applications need both hardware and software capable of performing at an extremely low power. The device's power consumption has to be under a milliwatt. Think of an application to monitor movement of animals in Kruger National Park in South Africa. There is no power supply in the middle of the national park to power up the devices, so it must be battery operable. And because the device is battery operated, it is extremely important for the AI to be small and efficient so that the battery lasts longer. I'm sure you wouldn't want to change the battery of the device every week, or else the maintenance would be just too painful and costly. Today's AI works by brute force. It's inefficient, wasteful, and expensive. That's why Xailient turned to nature to find a better way. Xailient brings ultra-low-powered visual AI for tiny hardwares. Xailient's deep learning-based computer vision models are just 45 KB in size and run at only 63 microjoules per image. That means an AI deployed to detect elephants in Kruger National Park in Africa would run on a coin cell battery for a full year. I use single-class object detection models from Xailient. Here's how you can reproduce these results. First, I would prepare my training dataset, load them into the Xailient platform, and then train a custom model. Other models like pre-trained face detectors have the same low power. You can do this with your own data. So why does this research matter? Deep learning took a new turn when AlexNet won ImageNet Challenge in 2012. From then to 2015, the size of the winning models increased 16 times. Deep learning models are no doubt improving every year, but pay the price in terms of increased model size and power consumption, making it extremely difficult to fit on low-powered, resource-constrained devices. So this is where low-power detectors come to the rescue. You don't need a GPU to run these detectors, nor do you need internet connectivity. And the best thing is that these devices can be powered up on battery. That means you can run your AI anywhere. Detection is the first step in every computer vision pipeline. If you want to count the number of cars in your parking lot, you must first detect cars. These ultra-low power AI models can be used as it is or as a first stage detector in the application pipeline. One use case is a face verification application. A face detector model can be run in always-on mode to act as a visual wake word. If a face is detected in a frame, only then is the face verification model activated. Here's an interesting graph of the power consumption over time for a face verification application. The spikes in the graph are when the face detector module detected a face, and so the face verification model was activated. If we run face detector model at 1 frame per second, then only 63 microwatts are consumed for face detection. While the face detector has the capability to run at 15 frames per second, in this example, we chose 1 frame per second to show how Xailient can further save power by running on a low frame rate.